So for the past two lectures, I have provided the class video on Carmen. Here's one of them. You go into Carmen. I don't know if you've ever had a completely online course before, but it's a lot like that. I just post it and you can watch it. I'm also uploading these to YouTube. So at the end of the course, when you might want to go back and review something later on. I know somebody asked last week, but I'll share that link to the YouTube playlist that I'm putting together that you can just keep forever because I leave them up there. So those are our videos. Go back to modules. So I'm going to start out. This is today's lecture, visualization. But I'm going to go back to last week. We talked a lot about importing data, manipulating data frames. I just need to import this one. We did a lot of stuff. I gave you a lot of information. I know. But this is, I don't expect you to remember all of it. I'm trying to give you a lot of terms to work with. Later on, maybe you're programming and you remember, I need to import a table, but I don't remember the command for it. So I'm going to go back to this example code, go back to the PowerPoint, find that command for importing data, see how it works, and import my data. If it's easier, just you can Google it and you know kind of how it's supposed to work. You can see that command and you can move forward with it. So we imported data. We looked at some things about our data. We learned that we can refer to a data frame and a column in that data frame by using this $ notation. I use that all the time. Okay, we can do math with columns if they're numeric. We talked about subsetting, filtering a table. You can do it with indexes, with square brackets, or you can use this subset command. You just have to think about what sort of logic statement do I need to put together to filter this data table. And once you filter it, take a look at it. See if what you expected R to do is actually what R is doing. You can check with this table function. That's a really quick way to ask what is in my table. Because the table function will look at a column, get the unique values for that column, and tell you how many times that unique value occurred in the column. Let's see. Just a lot of manipulating data frames through here. We talked about merging data frames. So there's all types of options for merging. You need to think about what is the column from my first table and the column from my second table that I want to use to connect these tables. That's our by. We can specify by from our first table, which is X, and by from our second table, which is Y. Think about, do I want to keep all the records from one or the other table? That's what we do with this all command. If we want all of the values from our first table, we include all.x equals true. If we want it from our y table, we could have all.y equal true. If we want to keep all the records from both tables, we just use all equals true. We also talked about converting from a long data frame to a wide data frame and a wide data frame to a long data frame. And I'll tell you, I can never do this just by memory. Whenever I want to do this, I go look up an example and I tailor what I need to do based off of that example. Think about what am I starting with? What do I need to group by? And how do I need to convert it to the other way? And then the thing that I didn't get to talk about is exporting our data. So we imported our table, we did some things to it, maybe we did a bunch of statistics. We have a data file, a data frame, and we want to spit it out to a text. So we use this write dot table function. We see the help for it just popped up right here. It needs a file. So no, it needs an X. X is our data frame. So this is our data frame. It needs a file. So that's where you're going to print your table to. Their file equals this string. It's a text file. We need to specify whether we want to include the column names from our table and whether we want to include the row names. So here are our column names. Here are our row names. Was that a question? Okay. So you get these are just true falses. If you want to include column names, set it to true. If you want to include row names, set it to true. Now, I talked about this in the last lecture that a weird thing happens if you want to include column names and row names. Because when it spits it out to your text file, if you say true for both of these, it's not going to hold an empty column spot for your row names. And so all of your columns get shifted over. So let's run these three examples. Oh, and then we also say the separator. What do we want to delimit our file on? Here's a tab. You could also do a comma, a space, whatever you want. And then another useful thing you might want to have or not have is whether to have quotes around your strings. I always have it false, but you might have an instance where it would be useful. Okay, so our first export, we have column names true and row names false. Where are we working? I need to get back to that folder. And it's right here. It's just a text file. And so we have column names and we do not have those row names. The row names were just numbers. They're not really even useful. So this would be our ideal export, I think. But maybe we did want row names. So the next one, our version 2, call names is true and row names is true. We run that. Where is it? Oh, here, it's right here. I was looking at the wrong name anyway. Okay, so this was our first one. Yeah. And then this is the one we just made. And you'll see this column is patient ID, but our patient ID column name is shifted back one. And it looks like these 1, 2, 3 values are getting assigned patient ID. It just messes up our columns. Now, if you wanted to manually fix this, you would just type in a tab and save this, and this would be your perfect file. So we could save that. We fixed it. But if you don't want to have to keep fixing it every time, like I used to do, you set the call names to be NA, and that leaves an NA value at the very beginning, very first column. I'll run that and we'll look at it. So here it puts in that empty space right here for us. If we would open this in Excel, this would be an empty cell. And setting call names to NA makes sure that that cell stays empty. That's only an issue if you want to print your row names and your column names out to a file together. Okay, so that's all about import and export. That catches us up. That's done. So for today, go into Carmen and we're on week 2, part B, R programming visualization. Download this zip all together. It's going to include a PowerPoint, this R script, and our expression table, which we'll use for heat maps. Okay, so I have a short PowerPoint today. More of our talk today is going to be going through examples of our code to plot the data in different ways. I have a whole lot of examples. We might skip some of them, but that's what most of our day will be spent on. So we're talking about today our visualization. Now in R, we have two options that we're going to talk about today. There's base level R. It's very basic. It's not very pretty, but it's built in. You don't have to install any packages. If you just want a really quick look at your data, what am I working with? You don't intend to publish it, just use base R. You get a quick look, you can move on with your life. If you want to make a fancier visualization to include in your publication, use ggplots 2. It's a special package from the Tidyverse. It's sophisticated and powerful, and there's all sorts of things you can do with ggplot 2. And something you might experience doing more complicated analyses, other packages, anytime really another package does some sort of visualization, it's usually using ggplot2 under the hood. So knowing a little bit about ggplot2, you can add on to that more sophisticated package plot. You can add your title to your plot. You can add some extra formatting because it all works using ggplot2. Okay. ggplot2 has a basic level. At the base level, you use the ggplot function to set up your table. You initiate your plot, telling ggplot2 what data frame you intend to use, and then what aesthetics you want to use. At the most basic form, you'll probably tell it what is your x-axis variable. What column from your table do you want to use on the x-axis? And what column from your table do you want to use on the y-axis? Some types of plots, they might only have x. They might not need y. You can also include things like color or shape in the aesthetics, if it makes sense. But aesthetics define the characteristics of your plot, and it tells the function what columns from my table are being used to plot. So we initiate that plot with the ggplots. It's not going to plot anything. If you want to plot something, you have to add on the plot type. And when you do that, it also has aesthetics you can specify. Here you can specify your color, your shape, anything unique to that plot type. And then the ggplots2 has an additive quality. You're going to see a lot of times where we have our base, we've saved it into G, and then we add on to it. So we've added saying we want to make a point plot, which is their way of saying a scatter plot. We want to use these colors and these shapes, and then we add more on to it. We want to add labels. We want to tell it our title of our plot. We want to tell it the name of our x-axis, the name of our y-axis, and then we add to it. We tell it a theme. Maybe my favorite theme is theme BW parentheses, and this just makes it all black and white, and it takes away that gray background from the plot. We'll see it later. Maybe you have a need to change the text size, and you can do that from within your theme. And then if you wanted to add on, you would put a plus after this, and then on the next line, you could put on more modifications to your plot. But when we make a ggplots to plot, set it up with the minimum that you can do. So initiate your plot, add on what kind of plot you want to make it. Look at that, and then think about, what do I want to change to this plot? Do I want to change my legends? Do I want to change my labels? Anything else you can add on. These are the plot types we're going to talk about today. There's histogram, density, they're sort of the same thing. There's scatter plot, there's a bar plot, box plot, and violin plots. They're very similar. And then heat maps. Now you'll notice everything except for the heat maps, I've included that ggplot2 chart type phrase for you. And that's what you would add on to your ggplots initiation. So every time you make a histogram in ggplots2, you'll add on geom underscore histogram. Okay. When we think about plots and we think about making them colorful and choosing color that best represents what we're trying to convey. Base level R has a color scheme that's automatically selected based on the number of groups you have, and I'll show that later. There's also set palettes. It's a group of colors that are set up together that you can choose from. Maybe if you want a gradient scale from white to red, it's going to have all of the different shades of red in between. So there's all of these palettes set up that we're going to look at as well. If you want to plan out your color scheme in a educational type of way, you make it a smarter pick. There's this colorbrewer2.org website and an R package that goes along with it. I'm going to go there. It's very fun to play around with. So it has different, so you can tell it how many groups you have, and then it has different types of color schemes. So this is sequential. This is if you want to have like from 0 to 100, some sort of scale in between. Your 0 would be white, and your 100 would be some dark color, and all of the values in between would be some sort of shade between that. There's diverging. This is something like you would use in a heat map where you have -2, 0, and +2. So that in this example, -2 is brown, +2 is the seafoam green, and 0 is white in the middle. So you can pick one of these that is pleasing to your eye. There's also qualitative. Maybe you have groups, and your groups, they don't really go in any type of order. They are just groups. We have a cat, mouse, dog, cow, horse. 5 groups, they're animals. There's no sort of order here. So we could choose one of these qualitative. We have 5 things. Yeah, these qualitative color schemes. Now, if you're thinking about publishing your plot, you might want print friendly or photocopy safe. If sometimes manuscripts, they want colorblind safe options. Now we can't have 5 groups and be colorblind safe. There. So here's an option of qualitative that colorblind individuals would be able to distinguish the colors well. So these are a lot of different options. If you want to, so here are the numbers that we can use to reference them. We can click on export and you can copy and paste them into your R like this. So there's 2 ways to refer to colors in R. You can refer to this hashtag letter and number name. You're not going to know off the top of your head. Or you can just refer to the color. You can say blue in your code, and R is going to know that's blue. So colors are always fun. So that's if you want to play around with colors. Let's see. You have shape choices. The shapes are usually named by a number. Let's see. Here are some shapes. You can refer to them. I'm gonna show you later those numbers and how they match up with their shapes. You can also think about dot size, line type. There's all sorts of options. These are the options for base level R, but similar things for ggplots too. Okay, and this is the other website we're going to go to today. This is the R Graph Gallery, and this is just amazing. It is a valuable resource if you're going to be visualizing in R. So there are all of these chart types. We're not going to be talking about all of them. We're going to be talking about like 5 of them. But like here's our first one, the histogram. This will tell you, it'll give you a bunch of examples of in ggplots 2 and in base R, how to make a histogram. And the very useful thing about this is, let's say you like this histogram. It has 2 variables and it shows you the distribution of those 2 variables in 2 different plots right here on the same plot. We could click on that and we could find the code of how to generate this plot right here. You can, let's see, you can highlight it all. I don't have R open yet. Not only does it give you the code, it also gives you the code of how to make an example data set for it. Let's see. See if this works. I didn't intend to do this. Oh, I actually don't have something that I need. I do not have HRBR themes. It's probably something to do with this shading. This theme, probably. We're going to take that away and this away. So it's not going to look exactly the same. I'm skipping ahead of what I intended to do, but let's see if this works. Oh, it's because it has this. I'm running it. Okay, so I've saved all of that into P. So now let's plot P. Hey, so I didn't have everything I needed to make this plot because I don't have this package, but I was able to recreate pretty well what they're making here. But it does have that gray background, which is not great for publications. I would add on theme, black and white, and that. Pink. And if you notice this bit of code, it saves it back to P. But if we just wanted a plot, we don't have to save it into a data object. We could just plot it. And since I added this theme black and white, it got rid of that gray background. So it just looks a lot nicer. Okay, so that was unplanned, but shows a good example of how you can use this resource to recreate what they've made and then think about how can I tailor my data set into this form and do something similar. Maybe I want to compare 2 different gene sets and show that the fold changes of these 2 gene sets are different. Okay. So now we're going to talk about each one of these plot types. And I've already shown you a histogram, but a histogram is going to show us the distribution of a data set with our x-axis being a value and the y-axis being how often are we observing that value. This is not really for group comparisons, even though we just showed an example where you could. A bar chart would be much more useful for a group comparison. This is for showing a distribution. There's 2 options that are you could choose from when you're choosing to visualize your histogram. One is the number of bins. You can specify that option bin and tell it how many columns do I want to have in my histogram. On the other hand, you might not know how many columns you want to plot, but you might know, I want each column to represent this width of my data. Maybe I want each column to be 10 units. And that's when you would specify your bin width. How wide do you want your columns to be? How much of the data do you want this column to be representing? So bins is how many columns do I want, where bin width is how wide do I want these columns to be. And we only specify one. You either get to choose one or the other, whatever makes more sense for your data. If we're using the base level R to make a histogram, it's really simple. We use the hist function. We tell it our table $ column, and it's going to pull the values from that column and plot your histogram. In there, I think you can specify the number of bins, but if you just want a quick look, you don't have to specify anything. With ggplot2, we initialize our plot, we tell it our table, and in aesthetics, we only have an X value. We tell it what column are we using. And then we add on our geom underscore histogram declaration, saying we're plotting a histogram here. And at the base level, that's all you have to do. It's going to use a default bin size. An alternative to a histogram is a density plot. It's basically the same information that it tells you, but it's been smoothed. There's no bin option. So when you plot a histogram, you can kind of play around with it to tell the story you want it to tell. With a density plot, it's all smoothed. So it's more like this is the profile of our data. And I show a density plot in the code a little bit later, but it's really similar. It's the same plot initiation. We give it one column, and then we add on geom underscore density with the parentheses. Now, I'm treating histogram and density plots as the same kind of thing. So this is our second plot type. It's a scatter plot. We've seen these a lot. We're trying to show a relationship between two lines of data, between two vectors. We have an X value. You want here it's value 1. And we have a Y value, which in this case it was made as value 1 plus value 2. So there is clearly some sort of relationship here. If we were in the statistics portion of this course, we would find a linear relationship between value 1 and our y-axis here. But we're not talking about that yet. But we see here each value from our data is one dot, and we see how the x and y axis are comparable. The base level of R, the function is just plot. We tell it, I'm going to plot, and we tell it our x-axis. Here I'm referring to a column using this index. So we get the first column from table 1 is our x value. For our y value, we get the second column from our table. We could also do this in that table $ column notation. We would have to know the names of the columns. So table $ column 1, if that's what the column was named, comma, table $ column 2. That would give us the same plot. With ggplots2, we initiate our ggplots with our table name, and in aesthetics, we tell it what we want the x-axis to be. It's our horizontal, is col1. That's the column name. And our y-axis, the up and down side, is col2. This isn't going to plot anything. until we add on our geom underscore point. It's a point for a scatter plot. Okay, so we'll show more examples in the code later. The third type of plot we're going to talk about is a bar plot. This shows a relationship between a number and groups. So here we have 4 groups, and we're showing the count of how often this group happened. This is a lot like what we would show in that with that table function. We table a column, and it's going to count how many times that value happens in a column. Now, when we do ggplots2 with a bar plot, you need to tell it whether you have already counted the things and your table has counts in it, or whether you want ggplots2 to count the things for you. So that's important. Okay, this is appropriate for counts when there's one measure per group. If plotting the average per group, you could include error bars, so that is an option. But it's a better idea to plot a box plot, I think. That way you show the range and the more information. So we're making a bar plot. Base level R, the function is bar plot. We tell it the values for the heights. This would be a vector. And then we tell it the values for the names, which would also be a vector. They're being pulled from our table, referring table $column. For using ggplots2, we initiate our plot with our table name, with our x value being group. It's a categorical variable, character string, and our y value being value. It's going to be a number. And then we add on geom underscore bar. That's how we tell ggplots2 to make a bar plot. And if you have done the counting already, we set stat to equal identity, because we tell it just plot the numbers that we've given you. If you need to count, if you need ggplots2 to count the things, then I'll show you how that works in the code part. So think about if you're doing the counting or if you want ggplots2 to do the counting and change this stat option appropriately. Okay, now this is our next type of plot. This is a box plot. It's very similar to a bar plot because it's showing a relationship between our measurements here on the y-axis and groups on the x-axis. Now, it is possible, if it makes sense for your data, to flip it the other way. You could have your measurements along the x-axis and your groups along the y-axis. You just have to switch which one you're assigning to x and y. It's the same information, it's just showing it in a different way. And that might make more sense for what you are trying to do with your data. The box plot, it's representing quantiles. And it also shows whether there are measurements in this data that are outside of the main bulk of the data. So these little circles at the top here of our cat column, they're kind of outliers because they are outside of, I think it's like 1 or 2 standard deviations from what our data is representing. But the simplest form, there's a line here at the bottom and a line at the top representing our range of data. That's our sort of our minimum and our maximum. Then inside there's a box. The thick line in the middle of this box is our median, I think. And then the upper and lower parts of this box, it's a special term called the interquartile range. And these are, one end is, where's my mouse? One end is the 25th percentile. And then the top part is the 75th percentile. So it's sort of like here at the zero, at the bottom is zero. Then our box starts, we're at the 25th percentile. The thick line is our 50th percentile. Then the top of our box, 75 percentile. And the line at the top is 100 percentile. You might also see the same kind of plot as a violin plot. And that's sort of a combination between a box plot and a density plot because a violin shows the distribution of this range on the side of the plot. And it's really easy to switch from a box plot to a violin plot just by changing that plot option. Oh, well, here's what I just told you, what a box plot is showing. And I got this straight from the R Graph Gallery, which is a wonderful resource. And this explains why we might have outliers, because they are outside of the typical range. So if you're wondering just what all the parts mean, this lays it out for us pretty well. So if you want to make a box plot and you're just using base level R, the function is box plot. You tell it the vector, you're pulling it from your table. So we use table $sign, the column name. This is measure, so this is our numeric part. Then we use this twiddle, and this twiddle is used as function notation. We are trying to relate our numerical measure with our categorical group, and it's sort of like we're doing a statistical test, but we're not going to talk about that yet. So all of this is saying is relate my measure and split it by group. That's going to plot a really simple box plot. Now you'll notice over and over again in the base level R, we refer to the table and the column in our command. In ggplots 2, first we tell the table, and then in our aesthetics, we specify the columns. So in your ggplots command, when you're saying what X is going to be, you don't have to say table $sign group. You only have to say group because we've already told it what data frame we're pulling from with this table listing here. It sort of makes our command cleaner because we don't have to type that over and over again. But here's we initiate our ggplots to function with our table, with our aesthetics. Our X value here is group. Our Y value here is measure. So we are relating our measure to these groups. And we're adding on that we want to make a box plot. If we were going to make a violin plot, we would have geom underscore violin. Let me see. I list them up back here. Here. Yeah, just violin, not violin plot. So you can switch that out as you wish. Okay. Okay. So those are all of the ggplots 2 base level R plots that we're going to talk about today. And then kind of something completely different. We're going to talk about a heat map because heat maps are very useful ways of conveying information about our data. It allows us to visualize for many different measures for many different subjects. So typically we're thinking about gene expression. And in this example, every row is a gene and every column is a sample. So there's probably 1,000 genes here. For 1,000 genes, we're plotting for 500 samples. So we have a lot of information here. And we can also ask, how do these genes, their expression relate to each other? And you can see these dendrograms. There's one for the genes, and there's one for the samples. And the plotting is reorganizing the order that the genes and the samples go in based on the similarities of measure. So it's going to look at two samples and they have gene expression profiles that are very similar to each other. They're going to be placed together in this clustering of samples up here. And what this heat map tells us, we're going to talk about it more in a couple of weeks, but it's telling us whether the set of observations, these genes, are they able to differentiate something about our sample information? And that is a good heat map. When you pick a list of genes that can split your samples into the correct groups. The important thing when you're making a heat map is you usually want to scale the measures. So we take one gene, one row, we find we don't really have to think about this because there's a command to do it. But what the command is doing is for one gene, it identifies the average expression for that gene and sets that average to 0. And then it thinks it scales the rest of the measures to be so many standard deviations above that average and so many below that average. So that in this case, a red shading will mean expression above the average, and blue shading will mean expression below the average. So we can see these genes, they're expressing more highly in this group of samples over here because they're very red all across this whole box. Where on the other set of grouping of samples over here, these same set of genes, they're all very blue, meaning that the expression of these genes in these samples, they're all very much below average. And this takes out the gene to gene differences that might exist. So one gene might have an average of 100, where another gene might have an average of 1. And scaling the data puts all of these genes on the same footing so that differences in expression level won't impact the what we're viewing in this plot. Now, when you get really comfortable with making plots, with using R, there are options for making interactive plots. And I do this very rarely because I'm not even completely comfortable yet. But Plotly is an R package for making interactive charts. So if you had a scatter plot and you wanted to hover and find out more information about this plot, you can do that with Plotly. It's sort of like ggplots too, but it's a different terminology. You have different commands, you have different options, but it allows you to make interactive plots that are really useful for your user. Now, we've talked about making plots, but our ultimate goal is to take these plots and publish them or share them with our collaborators. There are ways of combining plots into one figure. If you're using base R, you can have them as panels of one larger figure with the par command. Or if you're using ggplots 2, which you should be if you're going to publish, if you want to look impressive, you can combine multiple ggplots 2 with functions such as ggarrange from the ggpub-r package. And we'll show some examples of that. But this is how people, they have their one figure with panels A, B, C, and D. They do it by putting them together into one big picture, but have different plots. Along with this, we need to think about exporting plots. Do we want to print to a PDF where you can have multiple pages of plots? Or do we want to plot one plot at a time in a single file? we would use something like PNG, JPEG. Do we want it to be really, really high quality? We might want to use a TIFF or an SVG, which publication journals, they want those really high quality plots. So think about how you want to export your plots, who your audience is, how you're going to use that plot. Sometimes I'll show you how to export to these plots, and sometimes you'll be exporting your plots to a PDF. You open your PDF, you make the plots to it, and then you close the PDF by using this command dev.off with parentheses. Sometimes it will happen that you're running your code, maybe you messed up the for loops or something, and your PDFs got opened several times and they didn't get closed correctly. So if you ran your code, you go to open your PDF and it says this is malformed. Then you go back to R, you run dev-off a couple of times just to close the PDF. And then you try printing to that PDF all over again. You open the PDF, you print to it, and then you close it to make sure that your PDF is getting made correctly. Okay, so that's all I have to talk about in the PowerPoint part of our day. But what have we learned? I talked about some visualization methods for summarizing your data. I showed you how to use base level R and ggplots2 of all of the different types of plots. Now, when you think about all these different types of plots, think about how you want to present your data, what story you want the readers to get out of it, and then choose your type of plot based on that. We talked about there are options for combining your plots into one big figure. And I introduced that we're going to be able to export our plots to a file. Okay, so that's just the talking part of our day. I can close that. I can close this, and I can close this. So the R script I'm going to be using is this R visualization. When we get to our heat map part, we're going to pull in this expression table. So those are the two things you're really going to need. If you download the zip file, you'll get them all together. Let's see. Okay, I'm going to go through and open the file that I've already downloaded. I just downloaded it from Carmen, just like you. Downloads. Too many things. Okay, maybe I should have just, here it is. Okay, visualization. Okay, so I have a lot of different versions of all of these types of plots. And if I might not go through all of the different examples, but in your own time, you can go through them, try to understand what the different parts are doing and how one example is different from another. Like we changed the color or we changed the transparency. There's all sorts of things here. There's a lot of examples. So if you want to make a plot with a certain kind of shading, you can go try to find an example like that. But there's a lot here to choose from. So I have ggplots2 already installed. If you don't, I included the install packages command here for you, but it's commented out. So normally it won't run. If you want to run it, delete that hashtag, run this line of code, and then comment it back out. So we there. Now let's set our working directory because I'm not working right there anymore. I'm going to delete this. There we go. Okay, I go to session, set working directory, choose directory. This is not where I am. Okay, I'm right here. and that sets it up. I'm going to copy it out of history and put it right over here, going to source. Okay, so I've saved it. So I'll run it again. Now I said in the PowerPoint that R has a set color scheme that it picks from by default. I'm going to run this bit of code and then I'll go back and I'll talk about it. We can, you probably will not have to do this, but if you want to know what are the colors used when R picks two colors by default, R will always pick this salmon color and this teal color. If you wanted to know what is this salmon color really called, you can refer to it by this code. Sometimes you might want to replicate this exact salmon color, and this is how you can do it. This is the scales package, and I had it print for a value of 2, just like that. And it prints. What if we had 25 colors by default? These would be the colors R picks when you have 25. This might not be ideal because a lot of these greens and blues, they're all the same color. So if you wanted to plot 25 different colors, go search because somebody else, I'm sure, has put together the optimal 25 color panel. This is not an optimal panel for 25 colors. It's probably good for 4. Yeah, so these are very different. 16. No, I would not use it for 16. Okay, so that's the base R colors. If you wanted to look at some of these color palettes, here's that R color brewer. And I can ask R to display all the brewer palettes. I'm guessing these are a lot like where'd you go? A lot like the Color Brewer website that we just looked at. But these are those gradient colors. These are the qualitative colors in the middle. And these are those divergent color schemes down here at the bottom. If you want, those are especially good for heat maps. But you could refer to one of these by name. You could say, I want to use set 3. And it would, if you have 3 groups, it would pick these first 3 groups. So you can add them to your plot. So let's say you made a ggplots2 plot. You could add fill with this add-on of scale fill brewer and specify your palette, whatever palette you wanted to use. If you use scale color brewer and you're confused because nothing is changing, this is the command for changing the lines around your things. So definitely use fill if you want to fill. Now, I talked about dot shapes, and this will show us all of those dot shapes. Like, if you wanted a shape, you can fill in. You would use 21 through 25. These would be circle, square, diamond, triangle, and downward facing triangle. So these are shapes you could refer to if you wanted to plot certain shapes. Mm. I'm gonna clear that out. I need to, I had a phone call from daycare and I want to tell my husband. Oh, you. Okay. So now we're going to get into talking about these plots. I'm going to focus in on the ggplots versions since we have 30 minutes to talk about this. So first up, a histogram. let's see. Here is where the ggplot starts. Oh, we have to make our variable. That's true. Okay, so we're going to run this command. We're going to have 2,000 random numbers. What we're doing here, we're using the random number generator, plotting 2,000 values. What's I think with an average of 0, yeah, and a standard deviation of 10. That's what these are for. It's this one right here. So it's a random number right here. We are going to plot with ggplots 2. We're telling it use this table. It has a column called value, so that's what we're using for our number. And we're adding on the histogram. So let's see what that looks like. It's a very basic, this is the distribution of our value. It has an average of 0 and upstream and downstream a standard deviation of 10. We could, so in this first example, we have the value aesthetic in the ggplots initiation function. It's also possible to put that out in our histogram function. It plots the same thing. So either way. And now I'm going to show you how we can change the number of bins or the bin width. So the first one, we set bins equal to 10. So this is going to divide up our data into 10 equal sized bins. We're shading them based on this pleasant seafoam green color. The transparency is 0.9. I think as that gets smaller, it will get more see-through. The line color is this gray. If you notice, all around the bars are gray. We told it our title to be histogram with ggplots 2. I use this theme black and white because it's my favorite theme, and it makes it with black lines, there's gray lines in the middle, and the background is white. We also add on this theme to have a text size of 15. So you can play around with that. Think about what your plot needs and what options you might want to add on to it. Another useful thing to know about ggplots too, since we add on things, always make sure that if you're continuing to add things, this plus needs to be on the first line. So you see, we have our code, then we have a plus on the same line. And that's how R knows to go to the next line and keep doing things. Sometimes I'll see students have this, and R does not like that because it gets to the end right here and it just stops because it doesn't know to keep going on because the plus isn't there on the same line. So that's why your code doesn't work. Okay, we have another option where we set the bin width. So instead of having 10 columns here, 5, 6, 7, 8, 9, 10. Yeah, instead of having 10 columns, each column will be 10 units wide. So how does that change things? Doesn't change things at all. Okay, let's make them be 20. Now we have wider bins because each one of these bins is 20 units wide. Maybe we want them to be all one unit wide. We have a lot of bins now because they're all a lot thinner. If we wanted to make density plots, we add on geom density. And as you make your bin width smaller, let's see, let's make it 0.1. So that's not a great plot, but there. The smaller your bin width or the bigger your number of bins, the more it will approximate a density plot. We can add different color variations. So here we added on a color, a, a grouping. So if the value is greater than 0, it's assigned positive. Otherwise, assign it negative. And we include now fill in our aesthetic, in our initiation. We'll run one of these. And now we see values greater than 0 are shaded as positive, and if they're less than 0, they're shaded as negative. And you can see, since we have two groups, R just automatically picked that salmon and that teal color. If we had more than that, we would know, we could look back at our other plots and know what colors would be plotted. Let's see. Here's using a palette. So if we wanted to fill it with dark 2, they're apparently green and orange. Now, here we have all of the data together. If you have an instance where you want to split the data into two separate plots representing your whole data set, you add on this facet wrap option. And this is really powerful because now that we have group information, we could split this one plot into separate plots with a facet wrap. And let's see what that does. Now we have a panel for negative and a separate panel for positive, and they've been separated. That's what facet wrap does. If you don't like this order, so negative is over on this side and positive on this side, you could reorder your groups by factoring your column and setting the levels. So now they're switched. It's going to be alphabetical by default. Okay, so next up is a scatter plot. We're going to make some random numbers again. We're going to make the simplest scatter plot. Here with ggplots2, we're telling it we're using this my variable 2. Let's look at that. Some more observations. It has 4 values. We've done some math up here, so the values are connected. But we're going to plot value 1 and value 2, no, value 1 and value 4, and see what that looks like. There seems to be some relationship between these two values. If we look back at how they were made, so we had value 1, we had value 2. They're completely unrelated. But we add them together and we made value 4. So part of value 4 is made up of value 1. That's why there's a relationship here. We can plot the two. Here in our next example, I make it a certain color. I make it this light blue. Here we're referring to colors by name. I'm making the PCH, this is the shape, be shape 21. If you wanted to make it something else, we could go back and see all the way back, all the way back. No, I don't have it anymore. Oh, well, I won't do that. But you can pick one of those other numbers, like 25, and it's triangles. We can also specify the size of the dot. If you want to make them really small or really big, those are really big triangles. So you can play around, see what you want to, what story you want to tell with your plot. You can have variables for all of these different things. You could have a be shaded based on a color. So here we're shading based on value. I made these groups be whether they were both positive, both negative, or somewhere in between. And then I shade by that, and you can see that it really did work. These dots up here, both values are positive. These values down here, both values were negative, where the ones that were flipped opposite directions, they're in salmon. We can have this variable also apply for the transparency. It's not really suggested, but the lightest color, the most transparent, it's the in-between part. The most opaque is the positive, and something in between is negative. I don't know why you would ever want to do that. We can have the shape be controlled by our group. So double positive is squares, double negative is triangles, in between is a circle. That's the last one. Whoa. Okay, so here the size is being controlled by the grouping. Maybe you have an example where that would be useful. I don't know. Okay, so, oh, these are kind of important. Okay, maybe I'm just going to highlight this and we're going to get back to our base plot. Need to add on this. So this is what our plot looked like just at the base level. Then we add on that we want a line on our scatter plot. We're doing a linear regression model to see if there's a relationship. I said we weren't going to be talking about statistics, but here we are. It's asking, find a relationship between our y variable and our x variable and give us a trend line. I know I've done this over and over again in Excel, where you do that, find the regression, but you can do that in R too. You can ask it to lay that trend line down. You can have it add in the standard error. I don't know if you can see, but along this red line, there is a little bit of light greenness, and that is our standard error. We add that in by saying standard error equals true. And that error color is going to be this green, but it's barely there. We can also ask it to add in, so this is a different example. And we can specify when we're doing standard error, display the confidence interval to be a certain amount. And we see that here. We have it be less, and it's going to be a smaller part that it's showing. Okay, so that's scatter plots. Now we're going to talk about bar plots. We're making a new data. I think I can clear out all of these and these. Okay, so we have a new data table. And here we have done the counting. There's 4 groups, and these are the counts for each group. We're skipping the base R. You can go check it out later if you want to. Let's see, we're making colors. I don't know what the colors are, but oh, this is still base R. Okay, we're skipping ahead. We're not doing that. We're doing our ggplots version. We have our table. We have our X value, which is our groups. We have our Y value, which is our measurement. So that's up here. I tell it I want my theme black and white. And then I add on what type we're plotting. It's a bar plot. And we tell it that we already did the counting. And we tell it stat equals identity. Plot exactly what's in that table. Now, everything's gray here. Might be more useful to fill it based on group. Here, this one right here. Each one has a different color now. And this is that base R color, where it always picks these same 4 colors. If you wanted to specify your own colors, you could add on our scale fill manual. We could specify a palette, or we could give it a list of colors. Those are very bright colors. But here we say use set 2 palette. Those are a little more pleasing. They're pastel and they have a set scheme. So Think about how you want to shade your plots. What shading would give you the best story? What shading would be most acceptable to your manuscript? Maybe they want those colorblind safe plots. Okay, now we're making another data frame. And this time we're going to have ggplots to do the counting for us. So you can see here, we just have lists of A's, B's, C's, and D's now. We didn't do the counting like we did before. If we did a table, we did data one and group. There, this does the counting. It's going to be the same, but we want R to do the counting for us. We set up our ggplots. We tell it the group. The x-axis is this group. We tell it fill based on group, but we're not telling it a y because we don't have a y. We need ggplots2 to make the y for us. We add on my favorite theme, and then we add on our geom bar. But this time we tell it the stat is count because we need ggplots to count it for us. We're using this color set. So let's see. So ggplots2 has counted and it's filled based on group. So if you need ggplots2 to do the counting, you don't tell it a y value. And you also set stat to equal the count. If you don't specify stat, then it will count by default. Up here, if you have counted, you definitely need to specify identity because I think this will, yeah, we get an error. So the only time you don't have to specify the identity is if you want ggplots2 to count for you. You can also have split bar plots. So maybe you have subgroups in your groups and you want to have that be done. You can check out this link. You can check out the code to do that. Okay, now we're going to get into box plots. I have a ridiculous data set that we're going to make, and we're going to see how ridiculous it is. Okay, setting up our data frame. We are modifying the weight just a little bit, and we're making groups. If the weight is above average for that group, we're going to assign it an up, otherwise it's down. We can look at our table. What we are looking at here are different animals and how much they weigh. And then we have a group assignment of whether this animal is above average or below average. Yeah. So let's get a table. We have cats, chickens, cows, dogs, and ducks. And these are how many we have of each group and how many of that group are up or down. We get a summary across all of the weights. The smallest is 0.04, the highest is 36, and this has no units. We can just assume that it's pounds or whatever. I don't know. It doesn't make sense when we actually think about it. So don't think about it too much. Okay, we're going to make a box plot. Our X value is animal, so we're grouping based on animal. Our Y value is weight, and we're going to shade it based on animal. So each animal is going to have a different color. Okay, now it's a good thing that our cows are all the heaviest because that makes sense. We have a huge range of cats. Some cats are very, very big. Some cats are very teeny tiny. The chickens are all about the same size, but they might be humongous chickens. Okay. We're going to reorder these into a set order. Plot them again. And now I put them in sort of size order. Our cats on average are smallest. We have some really big ducks and dogs and chickens, and then all of the cows are biggest. So these have all been with box plots. If we want to switch to violin plots, we just switch the name to violin. We do that. And here on the side, you see, instead of boxes, we have distributions. So it looks like a density plot on the side of our line. And one thing we can state here is there is a wide range of weights for cats and cows. So there's a lot of animals at all ranges for these two types of animals. Whereas dogs, ducks, and chickens, most of these animals, they're all about the same weight. They're mostly average with a few outliers. We can also have a violin box plot where you still have that violin plot and you have a box plot planted on top of it. That way you get the most amount of information, but it's kind of confusing. So you might not want to do that. You can have your box plot and add on points to it. People like to do this a lot. This just adds it all up and down, so it's not ideal. What you want to do is spread out your points with this geom jitter instead of geom point. And jitter just kind of like shakes up the points, gives it a bit of randomness, so they're not all right on top of each other. That's better, but it's still not ideal. We could have it, we could specify width here. So they're more focused. They're not all in a line and they're not all over the place. They are focused more along that line. We can have a violin plot instead, but still with the jitter. Within these dots, you can also control the size of the dot, the color of the dot, the transparency of the dot, and you declare those things within the geom jitter part of the function. So here we're plotting gray dots that are kind of small and kind of transparent. We could have grouped box, let's see, I don't know what this is going to do. Okay, so here we are controlling, so all up to this point, we were controlling the fill based on animal. So every animal was its own one box plot, and each was shaded differently. We changed the fill to be based on group, that group that we defined earlier as whether that animal was above average or below average for all of the animal weights in our data set. So now we're splitting cats here based on whether that cat has a high weight or a low weight based on all the weights of our animals. So we're splitting by that down and up in our group. That's why there's two box plots for most of the animals. There's only one box plot for duck because all of the duck measurements were in that down group. So it might make more sense to facet based on group. So we saw that before. It's going to pull everything out in its own separate panel. Let's see that. So all the downs are on one side, all the ups are on one side because we're faceting based on group. And we're splitting based on group. What if we filled based on animal and faceted based on group? The same split, but it's shaded differently. A lot of these times, I don't know what's going to happen. So I try out a lot of things. And like, do I need to shade by fill? Do I need to shade by group? How does it look? We could shade by group and split by animal. Now that does not look so great because it's holding space for these other things that have no values. So we add in scale equals free to make the plot focus on only these two box plots for our cat, only this one box plot for our duck. So if you're going to facet and you want to have the plots be more focused, because it doesn't make sense to have all those blank spots, include scale equals free. And there we have that. In our last example, we set the color palette. We're filling based on group, we're splitting based on animal, and we tell it scale free. And then we fill it based on the set one palette. So it's a pleasant denim blue and Ohio State red color. So I don't start out by going straight to this nicest, fanciest plot. I start out the most basic up here, where we just have this. And then I think about how can I improve this? How can I make it look better? And then I might get down to here. Okay, the last thing I'm going to talk about is our heat map. So we read in this expression table, it has 94 samples, it has 586 columns. We can look at it. Yeah, the columns are genes, the rows are samples. We're going to scale the expression. This is a set function that it's going to center it and also scale it because both of these things are by default true. And this just describes what's happening here. So we scale it. And this is just a really simple heat map. Later on, we're going to use a fancier heat map package. But here, what we have done is we have our samples as rows, we have our columns as genes. And above average expression is in this dark orange, below average expression is in this lighter orange. We can, what does this do? Whoa. So this controls whether our columns are clustered and our rows are clustered. If we say don't cluster either one of them, there is no discernible pattern at all. Maybe if you put your nose up real close to it, something three-dimensional will pop out. But it just doesn't make sense to do that. Maybe we're going to cluster our samples by setting this equal to true. Rows V equal true. And now we're sort of seeing something, but we want them both clustered. That will look the best because it's sorting our samples and it's sorting our genes so that samples that have the similar expression profiles are together. If we just plotted expression, oh, it's going to complain. It says expression must be numeric. STR did expression. Yeah, well, they all look pretty numeric, but it doesn't like something. So we force it into, oh, it needs to be a matrix. It needs to be a numeric matrix for heat map. So we force it into a matrix and we plot it. This is just plotting straight expression. And you'll notice that it doesn't look as nice because some genes, just because they express that way, they have a higher expression than other genes. And they're sort of all on their own scale. That's why we scale the genes here and things get put back together. Doesn't cluster quite as well, but that is why we scale. There are other color palettes that are defined for heat maps. I don't use this heat map method. So I don't know what these colors are. The first one was like a cotton candy palette, and this is like a terrain palette. You can ask Color Brewer what are some good color palettes, choose one of those, or you can do what we're going to do later. get complex heat map and have it plot a very nice plot like we're used to with reds and blues. Probably not best for colorblind individuals, but that's what it does by default. Okay, in our last few minutes, I'm going to show this Plotly. I don't know a lot about Plotly, but this is an example that works. And if you want to use more Plotly, you can look up how to do things. So here we're making a scatter plot like we did before. We give it our data table. We say what value 1 needs to be. This is our X value, and what the Y needs to be. It's going to be value 4 on the Y axis. And if we hover, it's going to tell us the values that are underlying the data for these dots. You can change what this hover value is. Like maybe each one of these dots is a gene, and you want the gene to pop up and tell the viewer, the user, this is gene XYZ. We can also shade by different colors. You'll notice in this Plotly notation, it uses a little twiddle in front of the column names. That's just how it likes to be formatted. If you wanted to save this Plotly to an HTML, there's a package called HTML widgets. We make a plot. I've saved it in GG, but this is what it looks like. It's the one we already have. And then we run the save widget function, which will send GG to myplot.html. And if I went to my folder, this, I have myplot.html. It opens in Windows Explorer. Oh, and it has our group right there. You see the in-between text. Those are positive and these are negative. So that might be useful information to somebody someday. So that's all I have to talk about right now. When we meet back on Tuesday, I will go over the last few things because we got to talk about combining plots and exporting plots. So that's going to be the things that we have to talk about next week. Now, if you weren't here at the very beginning of